screen. Good. Do you have it?
Yeah.
Yes. So the way we talk about ecosystem services is that we want to develop ecosystem heroes. We want to visualize green capital so that basically nobody can anymore say, well, let's just cut down these trees because it has no value. Well, actually, trees have a lot of value. Trees are keystone species. And we as humans, we are tree-dependent species. So if no trees are anymore on this planet, we are also gone. It's as simple as that. So the older a tree, usually the higher those ecosystem services are. They are, however, species dependent and very difficult to understand and very difficult to calculate. So that's why we have this new collaboration with the Technical University in Munich, so that we can explain green capital in plain numbers. And we make it therefore impossible for corporate and government decision makers to ignore the value of the green spaces that we have in our cities. And Gloria and Lucas will explain you now how we do this.
Yes. I'm going to share my screen and I'm going to show you the new specimen page. Oh my God. Yeah. So, okay. Do you see me? You see my screen? We are already on the specimen page. I hope you know how to get here. It's actually pretty easy from the commons, and then you enter in your own commons, and then you will find the specimen area. And then you look for the specific specimen you are looking for. But today is the A01. It actually doesn't have a better name. We didn't give it like a, but we just gave him a code. Is a Tilia cordata, which is a small leaf lime, a pretty common tree in this area. And so you will see this is the picture of the specimen itself, judging from the trunk. This is the cover picture. But if you go below, you will see in the nature description, you will find a much better picture of it, which includes the full tree. And this is growing actually in a park here in St. Pölten, and is the only large tree in that park. And those are like, yeah, a couple of pictures of it, plus the number that you find in the culture part. Of course, I mean, when you will be creating your own specimen, then you can add more information. You can write anything you think is interesting to be added for that tree. And we also have, so what you will see here on the side, there is also like an edit button in case you are a common mentor, and so you are allowed to edit it. You will see the species, as I said. And you see the map. Look how beautiful it is, the map of St. Pölten, and you see exactly where to find it if you're moving around with the coordinates. And here you will see who added the tree. So Knut went in the park and took the picture. And then Lucas reviewed it and he thought, yeah, it's beautiful, let's keep it. And then, yes, that means you have St. Pölten and the ecoregions in which we are. Plus, there is a discussion tab in which you can definitely say something about this tree. For now, there is only this comment for Knut. Let's say that this is the only big friendly giant in Altona Park. And but what is more interesting in this page is actually, okay, let's the last measuring date, it was in August. And then we have some basic info about the trees. So if you have question about what they are meaning, you can see an eye on the top, which is a help button. I will start to explain you, I think, from the girth, because this is the only variable that we can actually measure directly when we go out. And we take, like, we measure it with a rope, usually at the breast height. So I'm going to show you now from the help button what we say about it. I say that the tree girth is measured at 1.3 meters from the ground, which is the breast height, by using a simple rope or a measuring tape. And this is an important variable for estimating age and ecosystem services. let's say we're close. Okay. And so through the GIRF, like we use it as a variable to calculate, for example, the age. Because of, I mean, if you know when the tree was planted, then it's really easy, like you just do this minus. But since for most of the tree we don't know, then we need to use a calculation. And this is what we say, that the tree grows by producing yearly a new ring inside the trunk. And in this way, tree girth increases with an average of 2.5 centimeter every year. Thus, tree age can be estimated by knowing the tree girth. If you do the tree girth in centimeter divided by 2.5, you will get an estimated age. However, this result is just a rough estimation of the actual age, which is highly influenced by tree species and habitat. So yeah, I mean, if you know exactly when the tree was planted, would be better than using this calculation. But
so maybe
yeah.
I just one sentence here.
Mhm.
In order to become a guardian in any city, you need to be able with very simple tools to go out and protect the environment. So what we do here is on the app is you only need a simple rope. You measure the circumference, the girth of the tree, you add it in here, and the rest is going to be automatically calculated.
Yeah, exactly. Also, the height is actually calculated by species-specific equation that are also dependent on the girth. I mean, you can also do it with laser tools, but you must own them, and it's not so important then to have them if you can use just the equation. Those will be provided by the University of Munich, as well as all the equation that we will be using for measuring the cooling power and the carbon storage. If you're wondering of something about cooling power, I can also give you what is saying here. So cooling power is about shading and evaporation provided by the tree. It strongly influences the microclimate surrounding the tree. And cooling power increasing exponentially with the side of the crown and the foliage. Because of course, bigger is the tree and more shading it will provide, and also more evaporation. It's also very much actually influenced by the land that you find below the tree. So if it's like asphalt or if it's grass, because half asphalt, of course, will like absorb a lot of heat, so it does diminish the cooling power.
Yeah, so here you also see an overview of all the ecosystem services that are provided. Yes. For those who don't notice, and 2 examples.
Mm-hmm. And and then you will see also here, like there is a graph, which might not be specifically about plane tree and chestnut, and here is showing you actually like that the cooling power is really species specific. So for some tree it does increase a lot with the age, while for our tree it just stays pretty low for the whole time.
Okay, that was cooling power.
Yeah, and then we close it and we move to carbon storage. Carbon storage is the ability of a tree to store carbon during photosynthesis. And all trees with big biomass have already sequestered large amount of carbon from the atmosphere. So what I was actually reading is that a tree on average will store about 25 kilograms of CO2 in a year. But, and for example, a human like me, like I did my carbon footprint calculation yesterday, and I use pretty much 4.9 tons of CO2, which means that to cover, which means that we need lots of trees to actually suck up all these carbons. So also in this case, we have like a graph example of 2 different species, and also here it show, for example, that Tilia with the age like more than 100 years, it's still like sucking up so much carbons, while another tree like the Robinia is actually diminished. So we will also get those more specific equations exactly from the university, because those are really complex otherwise to be determined about long studies.
这样子那个有的事儿也是一个小项目问题的。
Biodiversity richness instead is indicates the number of animal and plant species dependent or associated with a tree, and it increases exponentially with age and size. And also biodiversity richness is actually very difficult to be calculated. There are not that many studies that did it before. And so we are just showing a rough estimation. This is pretty cool to see, like a tree, like how the different part of a tree will host different type of organism, like from bacteria and fungi to birds and insects. And this is, for example, the common oak, which is one of the trees that hosts the highest biodiversity, at least in our climate. It has more than 2,300 species associated with it. And in the UK, 426 species were found to be obligated associates, which means that they are only found on these kind of tree. And therefore, the common oak is a keystone of our foundation species. And keystone species concept teaches us then the survival or extinction of one species can have a significant impact on all depending species. So, this is all what we are going to show for one simple specimen. This is all what it provides to us.
So maybe also here to summarize, the repeated exposure to those indicators will teach us more and more, deeper and deeper, the value of our environment. And this is the purpose why we visualize it here. Okay, so let's go into a Q&A on this part.
Yeah, maybe I would just add to it or mention that we try to make this whole thing playful, right? The way that you get the specimens on the ark, the way that you kind of win them is by going for a walk and visiting them. So you collect them inside of your profile. So you collect a card of it, like a Pokemon card. Yeah? And with these ecosystem services visualization, internally we call it the ecosystem superheroes, tree superheroes. So we try to give them the powers of 1 or 5 or 6. So then you think, this tree is stronger than that one. It's meant to be playful. So we're trying to merge in here the scientific part, being scientifically correct, and the playful part, where we want to make it more interesting and more fun for people who perceive the world a lot through digital media, to be brought more outside and learn more about what different natural parts of the planet do for us and for the world.
Yeah, it's a lot about citizen science.
Yeah,
it's a lot about playful citizen science. And you get 50 impact points on your profile for adding a new specimen.
Right. So this is all work in progress, and we're working with the TU Munich and also hopefully with another project next year to do tests. What is the most impactful way to present this? This is just a first draft. This will probably change a lot, and we want to see how to make the biggest impact in this way.
Any questions? Any thoughts? Any ideas?
I have a question. Yeah. So is this something, because you go into quite some detail in the description of the trees, obviously, and giving this sort of more scientific, let's say, categorizations. Is that something that Green Steps provide, or the mentor, or the what do you call it? Of a commons provides this, or this is collective learning, as in anybody who is part of the commons could come up with this sort of information?
Yeah, it's bottom up. Everybody,
Yeah.
every learner can create those entries. but the commons mentors are the ones who review and approve.
It's like quality assurance, yeah. Same principle like Wikipedia, yeah. So anybody can edit, but the edit is always reviewed.
Yeah.
Right now we only have the review process for the creation. The next step is the review process for the edits. So this is still also being developed, but the general idea and the way how it works right now is everyone can edit the specimens, everyone can suggest the edits and add the new ones.
So the general idea was to create least friction and massive participation. Everybody should be able to participate, but of course, then you have a problem with the quality. And also we want to strengthen those relationships between people within a commons now. So the commons mentors that have an advanced knowledge of flora and fauna, they are the reviewers. And it's really the same principle like Wikipedia, like Lucas said, because in Wikipedia, you can also not just publish. No? You submit, and somebody who is an editor will edit your content and then approve, or tell you, hey, please be a little bit more precise.
Yeah, okay. Yeah, that makes sense. Just if, because so many more people can contribute and come up with, there should be a much faster way of populating the site with information. Once you have the people participating.
That is also a process of learning. Like we are right now in the process of implementing it in a school. So then imagine this can be a class project of doing the mapping with the students, or maybe you publish just let's say skeleton entries, and the students have an assignment to measure the tree and add data into it, the review between each other. Yeah, so there are educational possibilities or opportunities also in the mapping and creating this database.
Yeah. That's our local strategy. We really want to go with this into the formal education system, and it looks promising for next year.
Nice.
And maybe I was also thinking, like, if I go now in somewhere, I'm now in Canada, so I'm as a tourist, I'm going through the city, and then maybe also there you can or I don't know if you already thought about, but that I get a map and I can see the city through these eyes and have like this game a bit also, or that this is like a map or something that you can, you know what I mean, somehow like tourist and
so
sorry,
the apps actually already exist.
oh, very good.
There are quite a few apps that are developed, but on a business basis, so they're really expensive. Then the cities pay also fees for this, and then they offer them. But what happens is basically that you are confined to this one route. They have to be curated by professionals together with the development company. It's not bottom up, it's not grassroots, and it does not extend seamlessly into other spaces. So what you can do on the Arc is that you jump, for example, from Zurich to Montreal, and you continue your learning there. Or like I have learned for a long time in Shanghai, and now I'm here in Europe. And I can combine my learning experience in one global commons. And that's what is actually the novelty. Such apps that you refer to, I recently saw in Belgium, one app is called Yox. They do it. This is already existing.
Very good.
Yeah, but I mean, we would also, like right now, you can only, let's say, experience the trees through guided tours. Yeah, so it is our intention to move into a self-guided as well, so that you can do this kind of geocaching mode. Yeah, this is something we would like to look into next year. So then you would be able to do that, and move into another city and go walk a route that has been crowdsourced, generated in a crowdsourced way with educational content.
Yeah. We really try to look a lot into gamification. So
Yeah.
if you have ideas how to make it more playful, then this is what we are really interested in.
Yeah, yesterday we just had a call with class from a project of European universities that we are collaborating with called OIDRES, and the students actually came up with a concept. They think their task is to come up with concepts of a companion app that would do the self-guided functionalities. So they are thinking about how to do this in a playful way inside of this project.
Okay.
Very good, thank you.